Hello, everybody. Welcome to the lecture on production systems and problem solving in AI. Here, we'll also see state space search for a problem. Now, let's see what is meant by a production system. Coming to the definition of the production system, this is a kind of procedure which is used in artificial intelligence, which will be easy for performing the search for solutions in a state space. And we also have components of the production system like start state and goal state. When I'm saying state space, the state space will consist of nodes and arcs or nodes and branches, wherein you have the start state and the goal state. And some databases are also there for task specific information. And you also have the production rules. The production rule have left hand side and right side. The left side will have the applicable rule and right side will have the action that is to be performed when that rule is matching with the current situation. And you also have control strategies for rule application sequence, that is the order in which the rules are applied. You are having some set of rules in production rules. Those rules will be chosen as per the current scenario and you'll try to solve the problem. Advantages of production system. Coming to the advantages of production system, one is strong modeling. It acts as a strong modeling tool. It is flexible and it is useful in real-time applications. When I'm saying strong modeling tool, it is effective for state-driven intelligent actions. That is, if left side matches a situation, then an action can take place. And coming to the next thing, flexibility. Here, in day-to-day life, sometimes if we try to develop any kind of computer application, new scenarios may be added. That is, changes may take place, and those changes are added to the existing system. The existing system is not disturbed, but it is added. And the other one is real-time application. Coming to this real-time application, we try to adapt new data and inputs, and the real-time changes are also adapted into the application. So these are the advantages for production systems. Example problem. We are considering missionaries and cannibals problem. And in this problem statement, we can see that there are 3 missionaries and 3 cannibals. And those 3 missionaries, you can see the river bank, a boat is present there. These 3 missionaries and 3 cannibals should move from the left bank to the right bank. So these 3, it is nothing but they must cross the river without cannibals outnumbering the missionaries. Cannibals will try to harm the missionaries. So we should see that. The problem is we should see that the cannibals are not able to harm the missionaries and the 3 missionaries should safely reach the other side on the boat. But there are some rules and constraints that are to be followed to solve this problem. What are those rules and constraints? The first rule is the boat can carry only 1 or 2 people. And the next thing is missionaries must never be outnumbered on the either side. And the goal is all the 3 missionaries and 3 cannibals should move from left bank to the right bank. So here in the state space search, we need to have knowledge about certain things. One thing is this state space search will result in a path from start state to goal state. And the key components are set of start states, set of goal states, or set of start states means the initial states. Set of goal states means the end states, that is, you have reached your solution. And when I'm speaking about a state space search, it definitely have nodes and arcs. And the path will start from the start state and reach the goal state. Coming to the definition, here we can just mention the start state, goal state, and intermediate state constraints for the missionaries and cannibal problem. Here, let me tell you, M means missionary, C means cannibal, B means boat. And 2 coordinates are there. One is left coordinate, the other one is right coordinate. So in the start state on the left bank, we'll be having 3 missionaries, 3 cannibals, and 1 boat. And when coming to the goal state, they'll go to the other side. That is, on the left side, it becomes 0M, 0C, 0B. And on the right side, 3 missionaries, 3 cannibals, and 1 boat will be there. So the count will increase and the count will decrease when moving from one side to the other side. And intermediate state constraints are also there. That is, we need to check that missionaries should not be outnumbered on any side. Next thing is, here I told you we have two banks. One is left bank, the other one is right bank. And each bank is represented as the list, like NM. N means the count for missionaries, M means the count for cannibals, and B means the boat. Start space is, you saw it, 3M, 3C, 1B, 0M, 0C, 0B. That means on left bank you're having 3 missionaries, 3 cannibals, 1 boat. And on the right side you have nobody. And intermediate state, it can be like N1M, M1C, and boat, so on. We'll see in the next slide. Here, these are the possible moves. What are the possible moves? Two people can move. Either two people can move or one people can move. One person or one missionary or one cannibal can move from left bank to right bank. So here, two missionaries can move from the left bank to the right bank or right bank to the left bank. And one missionary and one cannibal can move. And two cannibals can move. And one missionary can move. Or otherwise, one cannibal will move. Next thing is production rules for missionaries and cannibals problem. Coming to the production rules for missionaries and cannibals problem, we have left side and right side. In the left side, you can see that we have L1, L2, L3, L4, L5. And right side, these L2, L1 to L5 rules are rules for boat going from left bank to the right bank of the river. So when the boat is going from left bank to the right bank, if anybody moves, if missionary or cannibal moves or the boat moves, without movement of the boat, it's not possible, right? So the boat will also move. If the missionaries are moving, missionaries number will be decreased on the left bank and missionaries number will be increased on the right bank. And in the right side rules, that is from right bank to the left bank, on the right side it will decrease and left side it will increase because the missionary or cannibal had moved from right side to left bank. So here let's see the L1 rule firstly. Coming to this L1 rule, the actual rule, when can we apply this L1 rule? For all these rules, you have the same thing. That is N1M, M1C, and 1B, and N2M. N1 is for left bank, and N2, M2, so on will be representing the right bank. So if it is in such state, then what is happening? If I am applying the left side L1 rule, in the L1 rule, two missionaries will move from left bank to the right bank. So on the left side, two missionaries will be decreased. On the right side, two missionaries will be increased. And the other thing, L2 is one missionary, one cannibal. So on left side, and it becomes N minus 1 and cannibal M1 minus 1, and it is increased on the right side, as you can see for L2. L2, right side of L2, just observe last part, that is N2 is increased by 1 and M2 is increased by 1 and N1 and M1 are reduced by 1. And as both had moved from left bank to right bank, this bank had become 1. The other thing is L3 rule. In this L3 rule, two cannibals are moving. So L1, two missionaries moved. L2, one missionary, one cannibal moved. In L3, two cannibals are moving. So when two cannibals are moving, on left side it will be reduced by 2 and right side it is increased by 2. And in the case of L4, you can see that one missionary is only moving from left bank to the right bank. So N1 will be reduced by 1 and N2 will be increased by 1. N is representing missionaries count, right? So N1 is left side, it is decreased, and N2 is right side, it is increased. And coming to L5, you can see that one cannibal is moving from the left bank to the right bank. So on the left bank, M1 will be decreased by 1. So M1 becomes M1 minus 1. And on the right bank, M2 becomes M2 plus 1. Now coming to the rules for boat going from the right bank to the left bank of the river. So here you can see that two missionaries are moving from right bank to left bank. So on right side it decreases by 2 and on left side it increases by 2. And one missionary and one cannibal are moving from right side to the left side. So one is reduced on the right side and one is increased on the left side. And two cannibals are moving from right bank to left bank. 2 is reduced on the right side and 2 is increased on the left side. In the same way, one missionary is only moving from right bank to the left bank. So one is decreased here in the right bank and one is increased at the left bank. And one cannibal is moving from right side to left side. So on the right, one cannibal will be reduced and on the left side, one cannibal will be increased. Kindly take a picture or note down these rules so that you'll be able to understand the application of rules. In the solution part, I have only stated the rule number, that is either L1 or L2 or L3 or L4 or L5. So kindly make a note of this thing or take a screenshot so that you can follow it very easily later. Hope you took this screenshot. Now, the solution part for missionaries and cannibals problem. Here you can see that rule numbers are stated in one column and the states, how the states are changed is given in the next column. May I know what is the initial state? Yes, any one of you might told me, that is 3M, 3C, 1B. That is left side, you are having 3 missionaries, 3 cannibals and 1 boat. On right side, you don't have anything. So the count is 0M, 0C and 0B. That will be the start state. Now, this is the sequence, the rule numbers, the sequence, the control strategy. Here you can see that it is L2. First rule L2 is applied. In the case of L2, what is happening? You are trying to move one missionary, one cannibal to the from left bank to right bank. So on left bank, 3 will be reduced to 2 and 3 missionaries will be 3 missionaries and 3 cannibals will be reduced to 2 missionaries and 2 cannibals. And on the right side, 1 missionary, 1 cannibal. That is 1 is added there. In the next rule that we can apply here is R4. So when I am applying R4, what is happening from right bank to left bank? So from right bank only one missionary is moving. So one missionary move, he cannot be left alone there on the right bank. Okay. Because if he is left alone there, on the boat nothing, no harm will be done. But on the banks, if the missionaries are left there, the cannibal might cause some harm to the missionary. So what are you doing? You are trying to move the missionary from right bank to the left bank. So one missionary is coming here on the right bank. No missionary is there. It is 0M. And on the left bank, it becomes 3M. Next, coming to the rule, L3 is applied now. When L3 is applied, 3 missionaries and 2 cannibals. 2 cannibals can go to the other side. So if 2 cannibals are going from left bank to the right bank, on the right bank you have 3 cannibals there. Same next case is our next rule that can be applied. For next rule which we can apply is R5. So here when I am applying this thing, one cannibal is moving from right bank to the left bank. When one cannibal is moved, 3C becomes 2C. And on the left it becomes 1C. 0C becomes 1C in R5. When I am applying rule number L1, that is 2 missionaries. 2 missionaries will be moved from left bank to the right bank. We cannot leave there, so the boat cannot go empty. We can just transfer them. That is 2 missionaries are moving from the left bank to the right bank. So 0M becomes 2M. And next R2 rule is applied. That is from right bank to left bank. So you can see that alternatively the boat is moving from left side to right side and right side to left side. Therefore, those rules are taken. First left side, then right side, then left side and then right side. In that way it goes on. And now we have reached R2. In this R2, we can see that one missionary and one cannibal had moved. And the other things, these 2 missionaries had moved to the right bank in L1. Again, R5, what is happening? You can see that the missionaries or cannibals are moving from right bank to the left. Here, one cannibal is moving from right bank to the left bank. And again, in the next step, you can see that we can just apply the other rule called L3. And when you see that L3 is applied, you can see that here one cannibal here. One cannibal is moved from the left bank and he moves to the right bank. So it becomes 2C there. And sorry, two cannibals are moving from left bank to the right bank. So it becomes 2C there. Again, from right bank, we need to move something. So what are we trying to move is, we are trying to move one cannibal. When one cannibal is moved, on the left side becomes 2C. On the left side becomes 2C. Again, in the next step, what you can do, we can apply L3. That is, two cannibals will be moved. Two cannibals can be moved. If two cannibals are moved to the right bank, then we have reached our goal state. When the goal state is nothing but 0M, 0C and 0B. And on the right, you have 3M, 3C and 1B. Therefore, you have reached the goal state. Now we shall see a search space tree for this thing. Here in the start state, you have 331 and 000. 331 is three missionaries, three cannibals, and one boat. And on the other thing, you're having nothing. On right bank, you're having nothing. So here we'll apply our rules here. One missionary, one cannibal will move. When one missionary and one cannibal are moving, three will be reduced to two. Three missionaries will be reduced to two missionaries, and three cannibals will be reduced to two cannibals. And boat is not there on the left side, so it will be 0. And the other thing, we can just see that boat had moved to the right bank. So on right side it becomes 111. So if I'm the rule applied and arrow marks, you have left side arrow, you have right side arrow. When I'm having left side, when it points to the right side, then the boat is moving from left bank to the right bank. And if arrow is pointing towards right, from right to left side, the arrow points towards the left. So in this way, the rules are applied, and you can see that this state space tree is applied. And in this part, you also have some loops. Loops means invalid states. They are invalid, so we don't continue there. And in the leftmost part, you can see the solution, wherein in the previous slide, we have seen the rules that have been applied, and those rules are applied, and we can just see how the state is changing from current state to the child state after application of the rule. And finally, we reach our goal state. So this is our search space tree. Thank you. And here with this, we end our session or lecture on this production system and searching for the state space. Thank you.